So let's review some of the common DEF problems. One of the first ones that we're going to look at is dirt or metal contamination. If you do have contaminated DEF, you are going to cause abrasion of the DEF pump. It's going to gradually lose your tolerances over time. And one of the main culprits here is reusing dirty DEF containers. Another culprit is storing DEF in containers made of carbon steel, copper alloys, or zinc-coated steels, which is presenting a corrosion and rust issue. Crystallization is another problem, and what we're seeing here is essentially mineral deposits on the injector tips or in the exhaust piping. And the reason why this is occurring is because we're injecting too much DEF, and that's called overdosing, and it may not fully hydrolyze. The reaction may not fully occur. So this is leading to crystallized deposits in the exhaust or in the injector nozzle. And overdosing can be the result of partially open DEF injector nozzles, dribbling injector nozzles, or plugged DEF lines or DEF pump issues. Part of this has to do with turning the engine on and off and having that pressure still in the line when we restart the engine. Another potential reason for this is topping up the DEF system with hard water, which can also result in scalar deposits, but this is less likely than the first couple of scenarios. So in terms of urea concentration, it's important to have the right mix ratio of urea to water. If the DEF has been over diluted, in other words, having too much water, not enough urea, that solution is not going to be as effective at breaking down the NOx that you're trying to achieve, and your engine may issue a fault code. So that's usually not a problem. Most DEF is sold pre-mixed, but if you are topping up with water, it may affect concentrations. There is some potential for evaporative losses, which is why the urea test is typically measured on a frequent basis. Another risk factor with urea is the accidental mixture of another fluid, whether that other fluid is diesel fuel, engine oil, hydraulic oil, or coolant. That can cause a problem. DEF is a water-based fluid, so it will mix with coolant. It will not mix with diesel fuel, engine oil, or hydraulic oil. That's one of the field tests that you can look at to see if you have one or the other type of fluid occurring. Last problem that we have is cold weather. So DEF freezes at -11 Celsius, and if you are operating your engine below that temperature, it's important for that DEF to be melted for the SCR exhaust system to function properly in cold weather. Now normally the heat to melt the DEF is provided by the engine itself. Typically there is a coolant line running through the DEF tank, and that will actually add heat to the DEF tank in a small amount. Now there's a thermostat that would typically regulate that, and it would only turn on or off, and so there's some issues that potentially are the result of thermostat problems, which should be explored. Another way of heating the DEF tank is using an electrical DEF tank heater. Once again, if this tank heater malfunctions, it could produce too much heat and actually cause some of the evaporative losses that we were talking about earlier. In summary, contaminants or impurities in the DEF can cause problems in the SCR system, such as increasing your DEF consumption rate or reducing your SCR effectiveness. These problems could remain minor, but they could escalate and become major, preventing you from using the engine. So they should be explored and monitored. So DEF is normally tested when you are troubleshooting an exhaust system issue, or when you're confirming the DEF quality.